Hello, this is Mrs. Coffee. Today we're going to do an experiment called Chemical Change Lab, Baking Soda, and Balloons. You will need your CAMI recording sheet so that you can record the data as we do the experiment together. Today's question is, will the weight of the plastic bottle, which is over here, the vinegar, and the baking soda change after we mix the vinegar and the baking soda together to create a chemical reaction? We're going to do some research first using Moo Math and Science, the law of conservation of mass. After you have watched the video, I want you to form a hypothesis. If I mix the vinegar and baking soda together, I think what, and then you tell me what you think, not what I think, because sometimes I trick you and sometimes I write the right answer. So you never know what is true and what's false. So I'm going to give you an example, but you come up with your own hypothesis or prediction here. So I wrote, if I mix the vinegar and baking soda together, I think the weight will change. I think it will decrease because it's a chemical change and sometimes a gas escapes to the air. Okay, so what we're going to be doing is we're going to be putting baking soda and vinegar into this bottle, make a chemical reaction, and we're going to be putting a balloon on top and see what happens. So go ahead and write your prediction. All right, so to conduct the experiment, there are two items that I did not put on my materials list that I need you to add. I want you to add a funnel and add a scale to the materials list. So we're going to need a tray, a cup, an empty plastic water bottle, measuring spoons, 4 teaspoons of baking soda, 1 balloon, and 40 milliliters of vinegar. So we're going to gather materials on the tray as step 1. Come see me to get the vinegar. I'm just doing a demonstration today, so you don't need to come see me. You're going to measure 40 milliliters of vinegar and add that to the empty plastic water bottle. So I'm going to do that step next. I'm going to use a graduated cylinder to measure our liquid. Move this back a little bit so you can see. So you can see we have to go up to 40 milliliters. Okay, I just need a smidge more. All right, we're up to 40. So I am going to go ahead and pour that into the water bottle next. Okay, so the bottom of the water bottle has the vinegar in it now. Okay, next, add 4 teaspoons of baking soda into the balloon very carefully. So to do that, we're going to use a funnel. This is a funnel. And I am going to put the baking soda in the balloon using the funnel. So that is how we're going to do it. Okay, so we're going to put 4 teaspoons of baking soda in. So we're going to use the one that's marked TSP, which is teaspoon. 1, 2, 3, 4. Right, next, I'm going to weigh our bottle with vinegar in it and the balloon that has baking soda in it. So you can see it's got baking soda in the bottle. I'm going to put both of these on scale at the same time. So our weight is 3.49 grams. So we're going to write that on our recording sheet on the second page. So that's where you are recording that weight, 3.49 grams. Okay. Now I am going to put the water bottle with the vinegar back on the tray, and then I'm going to put our balloon on without dumping the baking soda in at this point. I'm just going to put that over the side of the balloon, or the side of the water bottle. All right, so it's ready for our chemical reaction. All right, so the next step is to pour the baking soda into the water bottle all at once. And watch what happens when the baking soda mixes with the vinegar. And we're going to draw a picture of that on page 2. And then we're going to weigh the bottle with the balloon full of gas. Record this information on your data table. Okay, so I'm going to pour that in. And you can see our balloon is inflating, full of a new substance. That new substance is called carbon dioxide, and it is a gas. So I'm going to weigh the mixture and see how much it weighs. It weighs 3.465. Okay, so I'm going to record that on the data table. So here we have the two weights. 3.49 was the starting weight, and then after the change it weighed 3.465. Now I will tell you that a teeny tiny amount of that carbon dioxide gas escaped from the side of the balloon right here where it meets the bottle. So that's why there's that little tiny amount that escaped. It's like very, very, very small. But if we were to round these to the nearest tenth, it would be the same, 3.5 and 3.5. So the difference is 0. So you could just write 3.5 and 3.5, and there was actually no change in the weight. The reason for that is because we trapped that carbon dioxide in the balloon. So it is a closed system. Now, if it was a closed or an open system and there was no balloon on top, you know it would lose some of that weight because the gas would escape to the air. So what I want you to do is draw your picture and label it, which you have your balloon filled with carbon dioxide gas, and I wrote that there was no change in weight, and you have the vinegar and baking soda mixture, the tray, and the graduated cylinder. You can include more items if you want in your picture. And then you have 3.5, 3.5, and 0 grams was lost. There was no difference between the starting weight and the ending weight. So analyze our data. What are the results of the experiment? What did we find out? We found out that the materials weighed the same because the gas was trapped in the balloon. It is a closed system. So my hypothesis was incorrect. The weight did not change because it is a closed system. The gas could not escape. That is it for today's experiment. You can see that it is still inflated from the carbon dioxide gas. Enjoy. See you later.